Good afternoon, everybody. It's great to be here. Yes, my name is Shannon, and today I'm talking about a small data approach to flow analysis. So I will be talking about the Orb observability platform that I've worked on and led for several years now. First inside of NS1, which was technology that we built out to observe the edge network at this managed DNS provider, and has now moved into NetBox Labs. And so we like to think of this project as hopefully helping to modernize network observability. And so quickly, a couple of the reasons we think it's pushing in that direction. One, it's a full platform. It's meant to work together well, and on the observability side, it's meant to have modular data sources, the ability to look at different types of data streams. We're going to talk about flow, but it's also very good at packets and now into device configurations and probing and other things. So it's meant to be flexible, and it's meant to be extended by the community as well. It's got a full fleet management system built into it. So NS1, being a managed provider with an Anycast network, has a very geographically distributed network. And so we had this need to run agents distributed across the world and to be able to program them in real time and get the observability we were looking for. And so it's actually based on an IoT platform, and it's meant to scale and run many agents. And very recently, we've gone all in on OpenTelemetry, which is the way that we build our data pipelines. I'll talk about that a bit. If you're interested to peep at that, it's at opentelemetry.io. And a very important point, too, for us is dynamic policy orchestration. So we try to avoid static configurations in Orb. We have a system for being able to reconfigure this fleet of agents in real time. And then we push this small data concept. And of course, that's in the title, so I have to explain it. Let's jump into what we mean by that. So of course, we picked small data in contrast to big data. And there is, of course, nothing wrong with big data. It's absolutely got its proper use cases. But inside of NS1, as we were thinking about our observability strategy, right? Again, managed DNS provider, and so we've got this edge network that's always on, serving a lot of traffic, and we're thinking about how can we dive into that traffic? How can we extract the information that we want to help us operate and protect our networks? This is actually originally built to be a DDoS production tool for us. And our thinking early on was, let's collect all the data all the time. That's the most flexible. That lets us answer any question that we would like. It turns out that's got a lot of challenges to it, or at least we found that inside of NS1. And over time, what we moved towards was the raw data itself isn't what we're interested in. What we're interested in are the insights that we can extract from that raw data. And that we learned that there was a price to pay for collecting all the data all the time for our use case. And so just to dive into that use case a little bit more, NS1 at this point is serving upwards of 1 million queries per second across its Anycast network. And we've done a lot of packet analysis, but to focus on the flow analysis as well, we were collecting something like 70 million flow records in a day. And there was a system, again, to collect this from the edge network. And pulling in that flow data for 30 days amounted to something like 3.5 terabytes of storage. And there were also, the system to do that involved custom pipelines and getting the flow in the right place and sometimes splitting it off so that we could send it to different tools to enrich it and dashboard it and so forth. And so we had a lot of challenges there. One, it was just hard to maintain sometimes, right? Having these pipelines work all the time, the configuration management to put it together, to maintain it, right? Sometimes engineers who would build the pipelines or the system would move on to other companies or other roles, and that type of thing can break down over time. And then even when we had all the data, sometimes it's hard to make sense of it, right? The question is, were we really getting the value out of collecting all that data? Were we really extracting the insights from all that data we were collecting? And that much data can lead to slow dashboarding, possibly short retention times. And even if you are able to store it and ingest it all, you may be paying for it, especially if you're using a SaaS provider or a cloud system. So all of that was in our heads as we built out Orb. So let me run through some features and the architecture. So we've also built it to be very automatable. So it is API first, as they say. There's a portal that sits on top of it that uses that REST API, and its goal is absolutely to be driven through automation. So I mentioned the fleet management piece. This is built into the system. It gives you the ability to create agents, provision them, see what their status is. Again, it's based on an IoT platform, and so the agents connect in, and we have the ability to see what they're up to and control them in real time. And we control them with these policies, right? And this is the way that we tell the observability agents what to do, right? So when an agent comes up in your network, it's not doing anything until it receives a policy and it's told what it should collect. So the other side of the collection is the syncing piece. And what we mean here is a data sink, a place to send the data. So it's important to note that Orb itself does not store the data. It does not have a database. It does not have a dashboarding system. It's the control plane that controls the agents, but then it allows you to create pipelines that connect into your existing observability stacks. And so that's what the sync management piece is. And also built into the system is essentially configuration management, right? So you don't need separate systems like Ansible to control your agents. That's built in to our fleet management system. We have the ability to address the agents that are out there, send them policies, right? There's a flexible tagging system to be able to decide what policies to send to where, what data pipelines to bring up across which agents. And then here finally again, OpenTelemetry. So OpenTelemetry is basically a group of folks who got together and decided on some standards more or less about how to represent metrics and logs and traces. And that gives us a lot of leverage to be able to build flexible data pipelines and process the data and sync them out to observability stacks that you may already have in place. Here's an overview of the architecture. So there's a lot going on here, but we'll break it up into 3 big boxes here. So on the left side is the edge collection piece. This is where you would deploy your agent either directly on top of or close to a device that you'd like to monitor. The central piece is the central control plane. So this is a cloud native application. You see the Kubernetes icon here, so it gets deployed into a Kubernetes. And it's where the REST API lives. It's what the agents connect into, and it's where you drive your automation through. It's also where the portal would sit there. And then off to the right, we have where you'll send your data. And so this would be syncing into something like a Prometheus or another time series or log system. And built on top of that, you have the way that you visualize, right? So this might be a Grafana, it might be a SaaS tool that's already out there that you're using, and this is where you can dashboard and set alerts and so forth. So if we look on the left side again, just to zoom in a little bit, what we're showing here is that there's an Orb agent that's been deployed on one of these servers. This is representing a geographic location, say that it's a POP in New York. And a single Orb agent can tap into many data sources. You can also deploy many agents inside of a POP. That's a flexible topology that's up to your use case. In this case, we're seeing like this green line come down, and we're just saying that in this case, Orb is acting perhaps as a flow collector, or maybe you're sending it packets even. And of course, here's where your fleet lives, right? So there's another pop up there. There's Amsterdam, and you would have whatever topology that fits your use case, connecting your agents here. And so when these agents get deployed, again, they're not doing much. You have to tell them what to do. And so this red line coming out is configuration that's coming from the control plane, right? And that might have been somebody going in through the UI. It might have been automation that's coming directly into the API. It might be a plugin, for example, from Netbox that's telling it that it should go observe something. And so the control plane is responsible for sending those instructions out to the agents. They start collecting data and then sending it back. And when they do that, they're sending it over pipelines that have been built up dynamically using OpenTelemetry that get back into the control plane. You'll see here it says MQTTS. That's the protocol we're using for the agents to connect into. The agents, by the way, only connect out to the control plane. There's no kind of ingress needed for the agents. And the data is collected by Orb and then sent out into your sinks. So a little bit more on the agents themselves. So of course, this is an agent-based system, and the agents are able to tap into many different types of data streams. So we're going to talk about flow mostly in this talk. That means SFlow, NetFlow, IPFix. It actually started as a packet analyzer though, so it's very good at doing packet analysis, And we've started to add other backends as well. So we've got what we call our net probe analyzer, and so that allows you to send ICMP probes and HTTP probes, DNS probes, and collect back time series like latency. We've started getting into visibility into device configuration via tools like SUSIQ. And this is a modular system, and so you can develop new backends to get new types of observability data into the system. So again, it's really important to us that these things are not statically configured. This is all configured in real time with the policies that are coming from the control plane. And for some of the things we analyzing, especially flow and packets, we have another tool, PacketVisor, which is responsible for doing smart aggregation, right, using fast streaming algorithms. And this really gets back to that small data concept of, instead of collecting raw data to some central solution, being able to filter out and to smartly aggregate directly at the edge and collect back this more insightful information rather than the raw information. And because you can spin policies up and down in real time, you can collect different data pipelines over time. You can spin things up while you're debugging. You can spin them back down. And so that's a key part of the system. So say a quick start here. If you want to get started with Orb to try it out, you're able to self-host the whole thing. So this is all open source. It's all in GitHub. If you want to self-host, you'd have to run the control plane itself inside of Kubernetes. We have a Helm chart for that if you have that experience. But that's a lot if you just want to try out the system. And so we have this website, orb.live, which is running the open source software directly in a SaaS scenario. And so just to show what that looks like, you can go to this right now. It's not commercial. There's no billing. There's no credit card. You click on register here, put in a little bit of information, and that'll drop you into exactly what it would look like if you ran your own Orb control plane. And inside of there, you can start to run through the process of setting up an agent. And so when you provision an agent, we'll give you instructions about how to run the Docker container. That's the easiest way to run the agent, although it's not a strict requirement. We do see a little bit of a configuration file here that's involved, but really that's just to tell this particular agent that it's able to act as a flow collector. And that's even something that we'd like to bring into the dynamic control plane in the future as well. And then the Docker command itself just has the credentials to get back into the control plane and start running. But again, as you start running that, you'll see it its status come online in the control plane, but it won't do anything yet. It's not collecting anything yet because we have to send it a policy. So here's what the portal looks like when you want to create a policy, and we'll go into a little bit of detail on some of these things. But policies are in either YAML or JSON format, and this is where you specify exactly what you're looking for, right? It could be a broad policy where you're just kind of saying collect everything, essentially. Or you might be really narrowing down what you're interested in. You might be filtering. You might be interested in some metrics, but not other metrics. You might want to do different types of aggregation. And all of that's supported based on which analyzer you're using. And those instructions are available on orb.community website you see here. We have to have a place to send the data to. Again, Orb does not store the data for you. It ships it out to a time series or another observability system that you either have in place or could spin up. And so you have to create at least one sink. Here's an example of creating a Prometheus sink using remote write. It's just a URL and some credentials. And once you've put all that together, that's when you can create your policy, send it out to your agent, and the data would wind up in your observability system, and you can start dashboarding, alerting, and so forth. So to dig into flow analysis in particular with Orb, this will be maybe pretty remedial for most of you, but what is flow data, right? These are records that represent connections that are happening on devices. And it's some pretty straightforward information, some IP address information, protocol, source and destination ports. But this raw data represents actions that are happening on your device that you're interested in understanding, right? And so this is sort of the raw data set that we want to analyze in some way. We want to extract insightful information from. And so the Orb policies for flow allow you to essentially define different ways to address that problem, right? So we can filter the data directly at the agent and really focus in on exactly the information you're interested in. We can enrich that data so that it makes more sense to a human operator. And again, we have this smart aggregation piece that can summarize in ways that can help operators as well. So here's what it looks like to add a filtering clause to a policy. Right, so Orb agents wind up acting as flow collectors, and so you would run them potentially close to the devices you would like to collect flow from. And filtering allows you to analyze this subset of flows that are going on. And so this is just one example of what you could limit that to. In this case, we're saying we're interested in only seeing flows from particular interfaces or devices. And it's key that you can expect a single Orb agent to run many policies at once. That's totally normal, right? An Orb agent should not just be running a single policy. You want to be able to dynamically configure these agents, send them a bunch of policies, turn down the ones you don't need, right? It's a dynamic system. So enrichment is in here, and this is really just to give the telemetry coming out of the system more insightful information, right? It may be more useful to see device names, for example, instead of IP addresses, or interface names instead of indexes, and so forth. And so we would do this enrichment directly in the agent, and so the metrics coming out of the system would already be labeled with this enrichment data. An example of that might be ports. Right? If you're looking at a graph that just has a bunch of port numbers that are unaggregated in any way, it's a pretty high cardinality metric, right? There's a lot of ports. It might not give you useful information in a graph. But if you can aggregate those into blocks that make sense and have them labeled, immediately the graph becomes much more useful. And so here we're using this port number registry that's freely available. This is built in, but this can be customized, and you can have whatever mappings you'd like. And here's a similar situation, right? IPs are even higher cardinality, right? And what you might want to do is to summarize them into certain subnets, right? And so inside of a particular policy, you could specify exactly how certain subnets should be aggregated together. And the hope is that would give you more insightful information in your graphs. And then same thing by ASN. And so it is worth noting that we do ASN lookup and geo lookup also in the agent. Again, we try to push as much as we can to the edge, to the agent itself. And we see also that you can be even as granular as aggregate things, but then exclude things, right? The hope is that it's flexible enough to give you the ability to be very explicit about a particular observability policy that you're interested in. So these are some of the metrics that we collect, actually all of the metrics that we collect on the flow agent itself. Each backend that is available in Orb has a different set of metrics. So for example, packets has an entirely different set of metrics. And these are kind of aggregated together. You can see that most of these have an in and an out, and a source and a destination version, sometimes a bytes and a packet version. And you don't have to collect all of this telemetry. You can tell via the policy what you're interested in. And again, back to the small data concept, if you're not interested in something, you don't have to collect it. So some of these are straight up counters and gauges. But on the right side, we see top-end metrics. And this gets back to some of that smart aggregation as well. We're using these streaming algorithms to get a top 10 list of certain dimensions of information here. And so, again, without having to go to the raw data and process it centrally, you'll have directly from the edge smartly aggregated top-end lists coming in as labeled properly as part of your metric time series. So back to the NS1 use case, going from raw flow records into an Orb-powered policy. For a 24-hour period, we set up a policy that had a certain amount of metrics enabled. The raw flow data that we calculated there came into about 200 megabytes of data, 3.38 million flow records. And with the Orb agent policy, filtering, and smartly aggregating. That turned into 163,000 metric data points, a mere 250 kilobytes. And the hope is that the operator was able to get out of this amount of information the same or more insight than having that much raw data. So use cases for this. So clearly operational value, right? This is certainly the way we use it inside of NS1. But in particular, it's great for debugging because you are able to spin policies up and down in real time. If you have a particular problem in a particular POP or area of the world or device, you can very easily spin up a policy that narrows in on exactly the data that you'll need to solve the issue. And then when it's gone, you can spin it back down. And because we're able to put this data into observability systems that already know how to do alerting and dashboarding and so forth, there's a lot of tools in this space now. We let you take advantage of those tools. And that's very helpful for working with other teams as well. And so if you have other teams that already have an observability stack and they're receiving telemetry on applications or other things that may be relevant, then you want to put that data together. This is a great way to do that. So we do think that there could be cost savings here involved because we're not collecting all that raw data centrally. And at least for NS1, this is a more reliable system compared to having a sort of duct tape together, configuration management piece that nobody that we had a tough time finding ownership for. So this is a cohesive system. Okay, I'm gonna wrap it up. Some key points that I would love for you all to remember. So Orb is a network observability platform. It's got exceptional support for flow analysis, but also packet analysis and other things. We talked a lot about this small data paradigm and pairing that with dynamic policies to make it very powerful, very dynamic system. Our goal is to integrate into modern observability stacks, which you may already have. And again, we take advantage of open telemetry to help us do that. And all of this is free and open source software, so it's fully available. We are on GitHub, and NetBox Labs now backs this project. And there. So what are we thinking about next? A lot. We think there's a lot we can do with this. Currently, we've been playing with device discovery and configuration monitoring, as I mentioned, as a new backend for our Orb agent, and in particular helping get device inventory into NetBox. In general, we've been working on various NetBox integrations, as you might imagine. Another plugin that we have available now is to be able to create NetProbe policies from inventory that's stored in NetBox. We'd love to integrate some other technologies that are natural fits, so GNMI would fit really well into our system, and we've thought about how to make a backend for this. And of course, everybody's interested in machine learning and what can we do with these data streams and how can we use it to the advantage of helping operators run their networks. And because we're open source and we're interested in community involvement, we're certainly open to ideas and hearing about your use cases and how we can work together to make a great system. Just some resources here. Orb.community is the main community website. We've got a Slack chat, netdev.chat, where you'll find Orb as well as NetBox and some other projects. We have that orb.live site. Feel free to check that out, play with it, give us your feedback, and everything is inside of GitHub. And that's about all I got. I hope that was useful, and I thank you for your attention. Any questions?
I'll start with the first question. You mentioned there's other agents. Can you talk about other agents, and are there any agents that are more on the active monitoring versus the passive monitoring?
Yeah, the only one we have on the active side right now is what we call the NetProbe backend, and so that's the one that's able to receive an inventory list essentially, and to send ICMP, DNS, HTTP probes and record time series metrics coming out of that. So I think that's failures, latency, and then a couple others, I think, depending on the metric. I'm sorry, was that your question? Or?
Since no one asked another question, have you thought of putting in a certain caching layer between the distributed agents, Orb, and the data sinks? So for example, because right now what it is my understanding is that you want to capture something, you deploy policy to the agent starts, but I don't have anything to look back. Let's say I want to look back a day or something. Have you thought of putting some sort of a caching where you could deploy a policy that would give you some data, maybe just looking back a day, and if that's feasible or not?
Yeah, we thought about that in a couple ways, I think. Part of that might be, there are definitely use cases to having the data available directly at the device. And so having the Orb agent have a look back could be useful for, certainly in the NS1 use case, it would be useful for the edge itself to be able to have a look back and potentially do some analysis, for example, anomaly detection based on a short history. I think that's not quite what you meant. There's the possibility of, basically right now we expect it to go into the data sync, and that's where the history comes from. The other part of this is we can start offering a built-in sync, which I think would essentially give you what you're looking for, right? So instead of having to send it out to another system, Orb itself could store it locally as part of a built-in sync essentially, and that is something we're considering.
Okay, thank you.
Okay, any other questions? All right, thank you very much, everybody.